Hello, and welcome to this Xilinx Quick Take video that will introduce you to partial reconfiguration for UltraScale FPGAs within the Vivado design suite. In this video, I will present new capabilities for partial reconfiguration, or PR, in UltraScale devices. I will highlight the new features and capabilities of PR within this new architecture, which is a tremendous step forward in this technology from Xilinx. I will detail new options and requirements for the reconfiguration process and introduce a new IP for managing partial reconfiguration. Finally, I will give some resources for learning more about PR technology. Note that this video does not cover the partial reconfiguration design flow in Vivado. For more information on the path through the tools, please see the Partial Reconfiguration in Vivado Quick Take video at the link shown here. That video shows the 7 series solution, which has not changed with the introduction of support for UltraScale. Partial reconfiguration in UltraScale devices is a major advancement in dynamic configuration technology from Xilinx. Like architectures before it over the past decade, UltraScale enables reconfiguration of the fundamental building blocks of an FPGA design, which are CLB, block RAM, and DSP resources, as well as routing resources to connect them. However, UltraScale introduces support for much more. Clock management blocks and buffers can be reconfigured on the fly, providing great flexibility for changing clocking characteristics as part of a partial bit stream. Gigabit transceivers can be reconfigured, enabling new possibilities for flexible network switch applications. And I/O resources can be included in reconfiguring regions, helping enable features such as field updates for tandem configuration. Design rule checks help guide designers to create appropriate floor plans to meet silicon requirements. The snapping mode feature automatically adjusts P-block ranges to match legal boundaries and is turned on by default. The only resources that cannot be partially reconfigured in UltraScale are those special components found in the configuration frame. Elements such as boundary scan, the internal configuration access port, and the startup block must remain in the static portion of your design. But wait, there's more. UltraScale offers improved support for devices utilizing SSI technology. The new Laguna interfaces that connect superlogic regions can be included in reconfigurable partitions, which means these regions can be as tall as necessary, even spanning multiple SLRs. The ICAP now has dedicated ports that echo the behavior of the external pins done and init-B. PR done and PR error are pins on the ICAP primitive that can be monitored by your design logic or Vivado debug circuitry to confirm that partial reconfiguration has been successful. Finally, the dedicated initialization for reconfigured logic that has been in place since Vertex 6 can now be applied at a finer granularity, providing much greater flexibility during floor plan creation. Let's take a closer look at that last feature improvement. UltraScale floor plans are comprised of a collection of programmable units. These base regions combine 2 neighboring elements and the shared interconnect switch boxes between them. When the global set reset, or GSR, is applied at the end of partial reconfiguration, only those elements within the user-defined reconfigured region receive initialization. The remainder of the device continues to operate unaffected by the GSR event. The granularity of this masking is as small as a pair of CLBs and their shared interconnect. For resources such as block RAM or DSP, the minimum unit is one of those elements paired with 5 neighboring CLBs. For the largest resources, like PCIe, CMAC, or interlocking, or for a single transceiver quad, the programmable unit granularity is a full clock region height. This pairs a single element with a column of CLB resources and the associated shared routing interconnect between them. When creating the floor plan in the Vivado IDE, note how the shading matches the programmable units selected within the P-block. Snapping mode automatically sends a legal collection of resources to be included in the reconfigurable region. Users can also dynamically apply DRCs to ensure all fundamental rules are followed. Examination of a new programmable unit shows a coarser granularity for I/O and clocking resources. An entire I/O bank consisting of 52 IOB, an MMCM and a pair of PLLs, clock buffers, and I/O logic contained in the Xi-Fi join a clock region height of 60 CLB as a single programmable unit. All of these elements must be reconfigured together. I/O characteristic changes are limited to ensure silicon safety. Another new feature for UltraScale is the Media Configuration Access Port, or MCAP. This is a dedicated connection from one specific PCIe block per device to the ICAP. No additional routing resources are required to bring 32-bit data from a PCIe link to the configuration engine, making this an efficient path for delivering partial bit files. This dedicated link is enabled by simply selecting an option when customizing the Xilinx PCIe IP. Speaking of IP, a new core is available to help manage the overall process of PR events and partial bitstream delivery. The Partial Reconfiguration Controller, or PRC, is designed to be the heart of a PR system. It is built with standard logic resources and responds to hardware or software-based triggers when partial reconfiguration is needed. This IP will first support 7 series devices before expanding to support UltraScale. The PRC is customized, either during IP creation or on the fly via an AXI Lite interface with a list of reconfigurable modules that it will fetch from local storage and deliver to the ICAP for programming when trigger conditions are met. Users identify the list of reconfigurable partitions and all the modules that will be reconfigured within them. Each is associated with a memory address and size. Software and/or hardware triggers are enabled, as well as handshaking routines to shut down, start up, and reset reconfigurable modules. Finally, trigger mapping is set, but this mapping can be adjusted at runtime. All these new capabilities in UltraScale FPGAs have necessitated the introduction of a new 2-stage reconfiguration process. Prior to loading a new partial bitstream, the existing reconfigurable module must be cleared from the active design. This process opens a mask for GSR to hit the proper target region. In this example, with a single reconfigurable partition RP1, the process looks like this. To transition from Module A to Module B, a small clearing bitstream specific to Module A must first be loaded. Likewise, to transition from B to A, a different clearing bitstream, this time based on the current Module B, must be loaded. These clearing bitstreams are automatically created and are about 10% of the size of the partial bitstream they are paired with before compression. The PRC IP will help manage these clearing stages. To learn more about partial reconfiguration in Xilinx FPGAs, check out these sources of information. First, the aforementioned quick take video steps through the features and capabilities of the Vivado implementation flow. The partial reconfiguration user guide and tutorial cover the PR solution in great detail, providing example designs and a scripting environment. Xilinx offers an in-depth training course for the Vivado PR solution. Additional lab materials are also available, and new application notes and examples are in the works. Finally, the Partial Reconfiguration Design Hub links all these documents and more within DocNav. To summarize, partial reconfiguration can help you realize new capabilities and new efficiencies within Xilinx FPGAs, using the easy-to-use flow and improved features within the Vivado design suite. The UltraScale family of devices represents a huge step forward in technological capabilities in the field of partial reconfiguration, a technology pioneered by Xilinx. We encourage you to examine the requirements of your next project to see how partial reconfiguration can help you. This concludes the Vivado Quick Take on partial reconfiguration for UltraScale FPGAs in the Vivado design suite. Thank you for watching.